Hello, I'm Ryan Chan, the CEO and founder of UpKeep. Today we're delving into the fascinating world of oil analysis tests, an essential tool for maintenance and operations teams. You'll learn about common tests like viscosity tests and particle counting and understand their significance in preventing equipment failures. So, let's get started. Let's dive right into the world of oil analysis tests. Some of the most common ones you'll encounter are viscosity tests, particle counting, Karl Fischer water titration, and various types of spectroscopy, including ICP spectroscopy and FTIR. Here's a fact to keep in mind: about 70% of all equipment failures are related to lubricating oil contamination. That's a huge number, and it underlines the importance of these tests. So, let's start with viscosity tests. These tests are all about determining the kinematic viscosity, or the thickness, of an oil sample at a set temperature. Imagine pouring oil into a tube immersed in a bath at a specific temperature, typically 40 degrees Celsius. The oil is timed as it flows down from one point to the other, and that time is used to measure its kinematic viscosity. By measuring the oil's viscosity at different temperatures, say 40 and 100 degrees Celsius, you get a viscosity index. And if the flow changes significantly, it could indicate problems like dilution or overheating. Next up, we have particle count tests. These are designed to diagnose excess amounts of particulate matter in the oil. There are several methods to do this. One is optical microscopy, where particles are counted manually under a microscope. Another is automatic optical microscopy, where particles are counted using a white light or laser. And then there's pore blockage, where the sample is poured through a screen that catches particles and slows the flow. Let's move on to the Karl Fischer water test. This test is often used after oil tests positive on a visual crackle test. In the Karl Fischer water titration test, an oil sample is placed in a vial with a reagent. The vial is then warmed in an oven, causing water to evaporate and collect in a separate container. This water then reacts with iodine, and the amount of iodine left over is used to calculate moisture content. Now let's talk about spectroscopy. Spectroscopy tests use electromagnetic radiation to measure the presence of certain elements. There are several types used in oil analysis. These include inductively coupled plasma, or ICP, Fourier transform infrared, or FTIR, rotating disc electrode, or RDE, X-ray fluorescence, or XRF, and atomic absorption, or AAS. Each method has its own advantages and drawbacks. For example, ICP spectroscopy is often used to find wear materials, but it can only detect particles up to a certain size. Choosing the right test is crucial. To thoroughly analyze an oil sample as part of condition monitoring and predictive maintenance, you'll likely need to perform multiple tests. But starting with the tests we've discussed today will give you a clear idea of your equipment's condition. Thank you for watching this video. We've covered the importance of oil analysis tests like viscosity tests, particle counting, Karl Fischer, water titration, and various types of spectroscopy in preventing equipment failures. Remember, 70% of all equipment failures are related to lubricating oil contamination, so these tests are crucial. Don't forget to subscribe to our channel for more informative videos. To learn more about our maintenance and reliability tools, visit our website at upkeep.com.